So as we move on in rational expressions, we just looked at simplifying rational expressions. Now we're just going to move on to the different operations: multiplying, dividing, adding and subtracting, finding least common denominators, because we're dealing with fractions. And so anything we can do with numerical fractions, we can now do with rational expressions for the most part. We can solve equations that have them in it. Yeah, so I guess that pretty much will, and then we can use applications. We can look at some story problems and things like that that will involve rational expressions. So at this point, we're just going to work on the multiplying and dividing because those are kind of the easiest operations to work with. So remember, and I'll give you a numerical example before I give you the rational expression examples. So remember with numbers, if you're multiplying, if I have something like, say, 5/3 times 2/7, you just simply multiply straight across, right? So 5 times 2 is 10, 3 times 7 is 21, 10 21st, okay? That's the final answer. Now, however, it is often the case that we can do some reducing. So you might have something like 2/7 times 3/8. And so you could do some cross-canceling or reducing between the 2 and the 8 before you multiply them together. It keeps the numbers smaller. So you could reduce down the 2 by dividing by 2, and reduce down the 4, or the 8 by dividing by 2, and you get 1/4, and then multiply across. 1 times 3 is 3, 7 times 4 is 28, okay? And so we can do multiplication using just multiplying straight across, or we can reduce first and then multiply, okay? If you multiply first, then you have to reduce with bigger numbers, right? If I multiply first, I'd have 6 over 56, and then I'd have to reduce 6 and 56 rather than 3 and 28. So it's a little bit more work that way, or at least a little bit harder thought process to work with the bigger numbers. So typically we like to reduce first, then multiply across. The same thing can be said with polynomials or with rational expressions. We're going to factor, when multiplying two rational expressions, we're going to factor everything down, reduce as needed, and then multiply everything back together, okay? So we might have something like x plus 7 over x squared minus 9 times 5x minus 15 over x plus 2. Okay, and so this example, again, I would like to factor everything that does factor and then cancel. So here, the numerator on the first fraction does not factor. The denominator does. It's a difference of squares. So we're going to get x plus 3 and x minus 3. Run out of a little bit of room, so we'll extend the fraction bar. Then we're multiplying. On top here, we can pull out a 5, so we get 5 times x minus 3. And here I can't do any factoring, so it's just x plus 2. Now, if I see a factor that's common to a numerator and denominator, in this case I have an x minus 3 on both the numerator and denominator, I can cancel those out. Okay? Then my final answer, and that's all I can cancel out. All the other factors are uncommon, right? We don't have anything common to a numerator and denominator. So once I've canceled those out, I can multiply x plus 7 times 5. Well, I'm just going to write it as 5 times x plus 7. The order doesn't matter when multiplying. And on the bottom, I have x plus 3 and x plus 2. Again, order doesn't really matter. Okay? This would be a sufficient answer in simplified form. Now, I would accept this answer. I actually believe my math lab will accept this answer, leaving it factored. Okay, there's nothing wrong with leaving it factored. So I'm going to go ahead and put a little cloud around this one. Now, you could, in theory, distribute all of this out, and it wouldn't be wrong. In fact, sometimes it's nicer to do that, and sometimes it isn't. So if you distributed this out, you'd have what, 5x plus 35, and on the bottom, if you do the FOIL method or distribute everything, it's x squared plus 5x plus 6 when you're all done. This is also a valid answer. I don't know if MyMathLab will accept that one. It pretty much will keep the factored form, but you could try. It depends upon what the instructions say, so always stick with what the instructions tell you. I personally would accept either one. The only drawback to the second one is that when we get more complicated polynomials, we may have more factors left over. You might have 3 or 4 factors on top and on the bottom. And when you distribute them together, you just get a long list of terms that really doesn't help you out in understanding the polynomial. So it may just be easier just to leave them factored and not worry about combining them. It's just extra added work and more room for error, okay? So I'm fine with you just leaving it in this factored form. But of course, expanding it is not wrong as long as you do it correctly. Okay, so that's the idea. You factor everything, then you cancel common factors and multiply out your final answer, or just at least write them in as products.